Good morning, children, and welcome to this, our second science class online. Today, we are going to be talking about motion. And motion is quite an easy idea, but it's one which we need to think about in more of a scientific kind of way, so that's what we're going to work out today. The first thing we're going to talk about is the vocab. Here the vocab is position. Position is where something is relative to something else. Speed. Speed is how fast something's going or distance over time. Velocity. Velocity is speed and direction. Acceleration. Acceleration is change of speed. And force. Force is a push or a pull. I think we're all pretty okay with that, right? We've done it before. I assume they all pretty much know it. So, we're going to think about the relationship between these three different things. So, if we start off with the idea that force, mass, and acceleration are in some way linked, that they must be in balance. And that's quite a difficult idea, maybe. But it's one that, if you think about it, makes sense in your day-to-day life. So, if you can imagine Oliver Puss, and he's going to push various things. A force is a push or a pull. So, Oliver Puss is going to push or pull something. So, put a force on it. And we're going to vary or change the mass of the thing that we're pushing or pulling. Here is something of a very small mass. I wonder what happens when Oliver Puss tries to push it. Woo! Oliver Puss, King Octopus! Wow! As you can see, it used very little force to push it, or to accelerate it forward to increase its speed. Now, what about something with increased mass? How about a table? Let's see how good Oliver Puss is at accelerating a table forward. As you can see, Oliver Puss found it much harder to push the table forward. He needed more force because it had more mass. So to accelerate forward, he needed more force because it had more mass. What if Oliver Puss needed to push or accelerate something which had a huge amount of mass? Imagine the thing that you know with the most mass possible. Imagine how much... Imagine how much force you would need to push something with an awful lot of mass and like... Okay, so here we can see that force, mass, and acceleration are all in a balance together. If I have something that has a certain amount of mass, and I want to accelerate it forward at a certain level, then there's a certain amount of force I need to do that. And that will balance it out. If I add some more mass, I need some more force. If I want to accelerate it faster, I need some more force. This sounds difficult, but is really quite simple. If I want to move a desk forward really quickly, I need a lot of force, a lot of push. If I want to move a marble forward really quickly, I just need a tiny bit of force, just a little push, and it will go forward really quickly. In the same way, if you want to decelerate something, the amount of force you need to make the acceleration go down is a factor of the amount of mass and acceleration the object has. So, for example, this marble has a very small amount of mass. So, if all of us needed to decelerate it, should be fairly easy, a small amount of force. Great, so the Oliver was easily enough there. The marble had a small amount of mass and it hit in with a certain amount of acceleration, and the force necessary for Oliver Puss to accelerate it was quite small. However, if we were to get something of much greater mass, for example, and we wanted to decelerate it, then it would involve quite a lot more force. So, anyway, we are going to talk about our experiment today. And our experiment starts off with a small hollow ball. As you can see, the ball is hollow, so if I put a little bit of force on here, look, it can be opened up. This allows us to vary something in our experiment. Those people thinking about the experiment today should think about what it is this allows me to vary. There are always a couple of variables we could try. I have this ball here that can be opened up, and I have some glue and some coarse material like sand or flour that would allow me to coat this thing here. So we're going to think to ourselves, what is it that we are varying? If I were to say, for example, add a marble into my ball, what are we varying in our experiment? The next thing we need to do is have another ball where we've added the variable, and our balls are going to collide together. So our balls are going to be apart, they're going to collide together. We're going to roll them along a flat surface, and they're going to collide, and then we're going to observe a result. So the next thing we need to think about is what kind of outcome are we going to measure? So the first thing we're going to think about is what thing we can vary, the thing we can change in our experiment. And the next thing we're going to think about is what can we measure in our experiment. Well, one of the key things we're always thinking about is the different forces that are at play and in balance in our experiment. So the first thing we think about is when I have my ball is sat there on a flat surface and it doesn't appear to be in motion at the moment, but we have to think about what forces are at play on this. So I'm going to ask Velocito to answer that question. So Velocito, what forces are acting upon my ball at the moment?
I think you will find I am not a velociraptor.
Yeah, I mean, I know you're not really a velociraptor, but to be honest, I don't know the name of the dinosaur that you are, so we're going to go for Velocito, because I know what a velociraptor is. Anyway, what forces are affecting my ball?
The answer you are looking for, teacher, is gravity.
Yeah, definitely gravity. Gravity is a force which is going to be pulling my ball down towards the centre of the earth. Okay, and what else?
Oh, teacher! I think the answer's friction, teacher!
Yeah, so that's also right. Probably friction is pushing my ball backwards. And because there's no push or pull force, then my ball is not moving at all. It is stationary. However, if I were to apply a force to the ball, it will move forward. So when we first have our two balls, one ball, two balls, and they move together and hit each other, we're going to accelerate them at an equal rate, and they should hit in the center. Same mass, same acceleration, same force. I wonder what we might expect to happen. Then we vary one thing in our experiment. So, for example, we might vary the force that we push them with.
Teacher, hold on now. How will we measure the force that we push it with, teacher?
Yeah, I agree, Jackazard. That would be quite hard for us to measure. So we might not want to use that as our variable, but we certainly could. So here, look, I have one ball. Here I have one ball. I accelerate this ball faster. I accelerate this ball slower. They hit in the middle. What might we reasonably expect to happen? Remembering that the force on push and pull is not the only force at play here. There's the force of gravity pushing it down, the force of friction pushing it back. So when I move them forward, I've increased one force, this push forward here. But have I changed any of the other forces? Certainly, if I were to change the mass of a ball, vary the mass, I would definitely have changed other forces. And if I was to change the surface of the ball, I would have changed other forces as well. So when I come to think about my hypothesis, I should think about what forces are at play here as the balls come together. What forces? There is gravity, there is friction, there is the force of me pushing it. How is that going to affect what happens when these two balls meet? This is key to our experiment today. On a quick note of warning before you do the experiment, I should say I've noticed that sometimes the balls do have a tendency to explode for no reason. So you have to be a little bit careful just in case you've got one of the exploding ones. That side, we'll have a quick chat about this, and then you do the experiment by yourself. If you can't do the experiment by yourself, perhaps some people could video their experiments and you can observe them doing that.